Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore an LLM inference engine named PowerInfer. So PowerInfer is an inference engine that is based on a technique called activation locality. That we'll talk about activation locality in brief, but it's really faster once you want to inference, large language models on a CPU or a consumer grade GPU. In the early evaluations and benchmark that PowerInfo creators or the community around PowerInfers, once they have benchmarked this technique or the inference engine, they found out that it is 11x faster than Llama.cpp. So we all know about Llama.cpp. If you don't know, Llama.cpp is also like a inference engine that helps you inference LLMs, on a CPU or a consumer grade GPU. Okay. Now, PowerInfer is really doing good at this moment. They support 8 models right now, but on a very high level, they support 2 models. One is a Llama model, and the other one is the Falcon model. So now, 8 model means that they have different weights variants of Llama and Falcon. So, for example, they support Llama 7B, 13B, and 70B GGUF format. So, the underlying concept is that it's based on activation locality. Now, there are two words, activation and locality. I'll keep it very layman in this video to you that you should understand what this mean. By the way, now activation, think of this like I'm giving you this information, okay, and once you process, not you, by the way, your brain cell, which is a neuron, once it process this information that I'm giving to you will get some result. That's what an activation is. That basically activates your neuron, which is a brain cell, right? That's an output that you get. Now, if you are familiar with deep learning, you should know about activation functions. Now, we have seen different type of activation functions that we have used in neural networks, like for example, ReLU as one of the example, and they also have their models based on the similar lines, ReLU and other activation functions. Now, locality is interesting because now imagine the information that I'm giving you is related to a technology which is artificial intelligence. Now, some part of your brain, the brain cells in a region that or a space or a proximity, they will only process this information which is related to artificial intelligence. And that's what locality means. So it's based on a technique, activation locality, which is really intuitive, by the way, fascinating to go a bit deeper and understand how this works. But it really helps compute certain type of data, or of course ultimately the information that you get in a temporal region or a proximity that only in that region certain data types will get processed, and that's where it helps you with the memory management and optimized inference that we're going to perform in this. And that's what an underlying concept in a very layman terms, but you can read the research paper which is also available, and you will find more information from that. Now, I will show you in this video that how we can, leverage PowerInfer to inference a couple of large language models within Google Colab. So let's jump in and see how we can set it up and build this to inference Llama 2. All right, so let's start our experimentation with PowerInfer, guys. So to use this inference engine that helps you run LLM at a very high speed, even on consumer grade GPUs, by the way. We're gonna do this in Colab notebook here on the GPU. You can see I'm gonna connect this with T4 high RAM. You can do that from the runtime. Go to change runtime and you will see some of the GPU options. A100 GPU, which is like Colab does not give you nowadays. Even if you have a pro subscription, so you have to wait for it. V100 is available. T4 GPU is available. You can see I am connected on T4, and I'm just gonna do a reconnect here. And here we'll write the code to inference it. Now, according to the evaluation which is available, there's a good performance when it comes to token generation rate that helps you around 13 tokens per second, and that goes to almost 29 to 30 tokens per second across several LLMs on a single NVIDIA GPU like 4090 or even similar GPUs like that. Now it is more than 10x faster than Llama.cpp. So it's of course definitely faster than Llama.cpp. And we'll see the responses, what kind of responses we are getting. We'll use a GGUF model, and I'm gonna show you that. But the first thing that we have to do is let's first, git clone. So I'm just gonna do git clone. Uh, and let's open PowerInfer. By the way, you can see the model is available here, the PowerInfer model. We're gonna use this model here. Let me just open this probably to show you. You can see this is here the PowerInfer community. They have some models, and these are the models which are available. And we're gonna use a Llama 2 model here. But let me just show you PowerInfer. If you go to GitHub, this is what we're gonna clone here. Okay. So for that, we need to clone this repository. So let's clone here in our notebook, and I have to write git clone, by the way, git clone, and let's just clone this repository. And once you clone it, you have to do a refresh. You will see that now a folder has been created here that's named PowerInfer, and you can see different subfolders and files are available. Okay, now let's do a cd inside it. So I'm going to do a cd and then PowerInfer. And if you do a present working directory, you will find that content PowerInfer is your folder. Now we're going to install the requirements. So let me just do pip install -r requirements txt, and it will install the requirements. If you come down, you will see there's a file called requirements.txt. That's the file that we're going to import here. That's not import, by the way, that's going to install. You can see these are the requirement. We have NumPy, and there are some versions as well that we have to consider. Sentence piece, which is a dependency of transformers. Then we have transformers, and then we have a couple of other things that it also gets installed. Okay. Now, to show you that, because this is going to be important, let me see. I wanted to show you something from here. Yeah, if you go inside the gguf pi, okay, this is something. If you look at here, it has a gguf pi, and then it has a PowerInfer pi. Okay. If you click on this, it also has some requirement. You can see these are the requirements, which is available in the 2ml file over here. You can see similarly the dependencies and all. Okay, fine. Now let me just close this. Now, once we do that, package install, we have to build it. So we're gonna use CMake to build. Okay, QBLAS BLAS, which are like a software that we're gonna build here. So let me just do that. Okay, so what I'm gonna do is CMake. Okay, and I'm gonna use, yes, this is a write command, and now here I'm gonna use D llama. It should, okay, it's not suggesting, though it's fine. And then if you have worked with llamas, you will understand. Okay, now we also have to do --build and config release, correct? You can see it says kubeless found. Okay, the CUDA compiler identification that this has an NVIDIA CUDA of 12.2 versions. It's gonna build this. It will take a bit of time to build it. Okay. So anyway, let's let it take time, and we'll also now write the next piece of code for to download the model. So here we're gonna download the model. So let me just do download the model, and in the model I'm gonna download it through. First, let's create a directory. So maybe we can create Relu Llama. So they have Relu Llama. That's one of the supported model that's provided by uh, PowerInfer. I'm gonna use a 70B, so let's give 70B PowerInfer and gguf. Or you can also try it out the smaller ones. For example, if you look at, we have here different models. It has supports 8 models. It has llamas. You can see 70B, 13B, 40B, 7B, 13B, 7B. So different types of model that it supports. Let's take let's take this 13B model. Okay. So let me just take the 13B model here. Copied. Now I'll come here and let me just come. And you can see I'm just gonna make a directory for 13b. Okay, so it says okay, create a folder name of this Relu Llama 13b PowerInfer gguf, and maybe we can also do okay. This is still it's happening. It will take a bit of time. Now, once you create the directory, we're gonna use wget command. So let's use wget, and then you give the path of your model. Okay, so now 13b. So this is fine. So let me just give 13b, and then we get it from Hugging Face. We're not gonna get this from Git. So let me just delete that. So that this part is right. Now what we are saying is, okay, you download the model in this folder that we have created, or the directory that we have created. Now Relu Llama 13b power info gguf, and just I'm gonna come here on this repository, copy this. So let me just copy it here. Okay, copied. I'll come and I'll paste. Now, you cannot just give this because you have to again give the entire path. So let me just do this will not help you get through wget. So let me just come here in 13b. Then you have something called files and version. And then you have this here. Now you have to get this complete URL, okay, of the URL that you see on top, and we'll remove a few things. I'll show that. Okay. Now let's come back in our okay, let me just run this directory thingy. Okay, the directory thingy is done. So if you go to PowerInfer, you will see there is a new folder called Relu Llama 13b PowerInfer. Now in that we're gonna do that. So you can see what I'm doing here. I'm saying okay, you have your HTTPS huggingface.co, and then you have your PowerInfer Relu Llama 13b PowerInfer gguf. Now we'll not use. Just give me a moment here. Okay, we'll remove blob to resolve. So let's do that. And then you have main, and then you have your model name. Okay, so if you look at your model name, it says Llama 13b Relu Power Info.ggf. This is a model that we're gonna download. So let's do that. Now this will take a bit of time because it's a big model. It's like in almost around. If you come here, it should be around. You can see size of remote file is like 28 GBs. If you go back, you'll see it's like 28 GBs of file. It's a huge file that we are downloading it. So it will take a bit of time. So what I'm going to do is I'm going to pause the video and I will come back once it is done. Okay. Or maybe let's it's happen. Okay. Because I think it's too fast. So I can just add few more cells. So it's fast. So what I'm going to do is then we have to perform the inference. So let me just write performing inferences. Okay. Performing inferences. And in that inferences, what we're going to do is again we have to build. Uh, so you can see it says build Relu Llama 13b to not exactly. So build is right. Then I'm just going to do inside bin and then main. Excuse me. And then you have your model path, so that is right, but that is so if you want to give double hyphen, which is fine, but let's make it as a single hyphen as an arc. So I'm going to give as m, and then it takes your to Relu Llama, and now let's see Relu Llama 13b. This is the I think the model name, blah blah blah, and then again we go to the next line of it, and then we'll say maybe what would be the new token. So let's keep it like for testing, let's keep it very small. And then again, there should be your number of threads. Okay, so let's keep it like 8 or something. Okay, and then you give your prompt. So I'm gonna give, for example, what is an AI? Okay, something like this. Okay, or if there's not instructions, what we can do is AI is a technology. AI is a technology, and let it complete. Okay. Now what we are doing, if you look at closely, we are saying okay, you build from here, which is your model, and then you use n, which is your new tokens, and then your threads. And now let's see what it gives. So I think there's a spelling mistake. Now, if you look at this folder, we have a new model. If you just let me just make it a bit bigger, you can see the model which is here, gguf. And now what I'm going to do is I'm going to run this here. So let's run it and see. And you can see it started building it for you. Okay, the inference that we're going to have. So let's come down. It will show you all the model pipelines, model, the way that it infers it. You can find out all the descriptions. It's a bit verbose. Okay, and let's count the time as well here, guys. Okay, you can see it below. We are getting the time. For the first time, once you run it, it will be a bit slow. From the next time onward, it's a bit faster. That's what my observation is here. So let's wait for it. So it's a 13B model. You can see that we start the model from 7B to 70B. Okay, so it's a 13B model that we are using on a T4 GPU. So if you go a bit higher on V100 or A100, it will be even more faster. But let's try it out to see. So if I go a bit up, you can find out all the tensor over here. It says log start built with Ubuntu, that we also currently, this Colab is based on a Linux distro. And you can see out found one CUDA device. It detects your CUDA, which is Tesla T4, compute capabilities, and so on and so forth over here. And you can find out different tensors, layers, etc. The tensor layers. Now let's come down. You can now see it says VRAM used. Yeah, around 10 GBs of VRAM has been used over here so far using CUDA for GPU acceleration. And you can find out over here the system RAM and the disk and the GPU RAM. And now you can see it starts generating the token. But if you look at the streaming response, once it started the response generation, it's really fast. So for the first time, it will take a bit of time, but the next time onward, it's really fast. You can see it says AI, the technology that makes machine perform tasks typically done by humans, can help in a wide range of applications, blah blah blah, right? So yeah, this is fast. Now you can see the token that it's generating. Yeah, you can see the log end. Your sale has been completed. Now, if we look at the uh, by the way, here that's where it's end because we have a new token as 128. By the way, now it says you can find out the time it took to generate the tokens, load time, sample time, prompt evaluation time, eval time, and total time that it took, to generate. It took 2 minutes 52 seconds for the first time we ran it. Now, and you can see the VRAM that it used is was around 10 GB. By the way, it's not able to see right now here, but it was around 11 GB. Now let's see that 11 GB, okay, of 13B. It took around 0.59 ms per token. Okay. Now, if you come to, it also has a feature where you can, inference execution. So let me just write it. So inference execution with limited VRAM. So let me just write limited VRAM uses. Now here you can also use that. So let me just first run this. Now where you can set a VRAM budget. That's what you can also do if you have a limited VRAM. Now the model remains the same, the context remains the same. Then we're gonna pass our AI, the technology, and then I'm gonna write not max VRAM, for example. Here you have a VRAM budget. So for that, let's write VRAM, and then you write budget. Yes, correct. Now I'll keep it like let's keep it 8 as your VRAM budget. Okay, and now let's run it again and see what happens. And now you can see it's faster because you are running it for the second time. The first time it takes a time for the build. Now you can see how fast it is, extremely fast. And if you look, it goes to 8 GB, not more than that. So you can set a budget for your virtual RAM, which is fantastic. Now, if you look at it, and now imagine if you are using it locally on a single consumer, because we are using T4 by the way. We're using a T4 GPU with just a bit of high RAM, and we are able to run it. And you can see the number of tokens it generates per second, extremely fast, isn't it? AI is a technology that has been around for decades, and it uses use cases, blah blah blah, extended to a wider variety of different industries, and it's in front of you. So now we've limited to 8.1 GB, which is fantastic. Uh, Now you can also think of using this in production as well, but it depends where you are running it. But now it shows the capability that it's faster than Llama.cpp, by the way. That's what evaluation says. If you go through the documentation and their GitHub repository, the benchmarks that they have done. But this is what I wanted to do, guys. I wanted to create a small experimentation where you can, use this for your inference of this Llama 13B or 70B models and other models that they currently supports using PowerInfer. That ends our experimentation, guys. That's all for this video, guys. I hope you learned that how you can inference this power infer inference engine that helps you, run these LLMs on a CPU or a consumer grade GPU, as like we saw in Google Colab on a T4 GPU. Now you can play around it. A code will be available on my GitHub repository, the notebook. You can take that, try it out yourself. Maybe you can, scale this further in some kind of production deployment and see if that's helping you in some of your use case. Now, if you have any thoughts, feedbacks, please let me know in the comment box. And if you like the content, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel. Share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.